All right, we're going to walk through some of these limit statements again, but we're going to change them just slightly. Okay, we are still going to work with 2 points on the graph. Okay, there's my first point, x and f of x. We are still going to work with the second point right here, x plus h. There's my second x coordinate. And then we've got the other y coordinate. I'm just going to write it up here. F of x plus h. Now what we did on the boards is we found slope at 1 point. Well, it's kind of slow if you would like to find slope at any point on the graph. You don't want to have to work out that limit statement every time. So we're going to start with average rate of change. That's just slope between 2 points. Now the 2 points are highlighted up here. Here's the first point, x, f of x, right? X and y. Here's the second point, x plus h, f of x plus h. Those are my 2 points on the graph. That's average rate of change. So f of x plus h minus f of x all over x plus h minus x. That is average rate of change because it's slope between 2 points. Now, what I'm going to do is we're going to turn that into instantaneous rate of change by making the distance between the points 0. It is almost the exact same formula as what we just did on the board. The only difference is that this is an x and not an a. That's the only difference right now. And I do notice that those things cancel. Okay. Well, this is not at a number. This is the instantaneous rate of change at any x value. I don't want to plug in the number first. I want to plug in the number last. Okay? That means it's going to create a general formula. And we're going to see how this simplifies. Okay? Now, this is, okay, formula, instantaneous rate of change. Should be pretty similar. It's just this time I'm leaving an x there. Okay? We know that the tangent line is connected to the tangent slope, but I'm going to add a word. Derivative. Okay, limits are the foundation of calculus. There are 3 semesters of calculus, A, B, and C. Derivatives is calculus A. We are about to start derivatives. Yeah. Yay! Okay, so derivative is tangent, slope. Okay, it's also the instantaneous rate of change. It is also, I'm going to say, a formula. It's a equation or formula used to find those 2 things. The derivative is a formula used to find the tangent slope or instantaneous rate of change. Notice all of our answers were numbers. That was the slope at a particular point. Okay? The derivative is an equation or a formula used to find that number. Okay, now I wrote the definition down here for you. I'm going to skip the alternate for now. Okay? And we're going to look at the notation. The notation is f prime, looks like an apostrophe, of x. And we say f prime of x. That's how I would say it. It looks like an apostrophe. We say prime. Prime is what means I'm talking about the derivative. There you go. I got you. There you go. Okay, what's another notation? dy dx. Slope. Okay. Literally, you just say the letters dy dx. dy dx. Right, that's how you say it. I'm not saying dy divided by d. It's just dy dx. Change in y over change in x. It means slope. Okay. What's another notation? What does it look like? All right, this is... Okay. Sometimes the y value is put in front of the fraction. Okay. And I'm going to put a bar here. I'm going to say x equals a number. And I'm going to translate. What does that notation mean? It means dy dx at x equals a number. Oh, instantaneous rate of change at x equals a number. This is for evaluating. It's like finding the number. Sometimes I can change the letters. Like maybe I'm looking at a position graph and I have height. It doesn't matter what the letters are, the apostrophe or the prime, and I try to make it slanted so it doesn't look like a 1. It's not a 1. It's not a number there. It's just a dash. Apostrophe looking. Okay? So H prime. You're like, this notation is really crazy. We'll do a lot of notation, guys, all right? Your goal today, yes. Should be T. It happens a lot. All right, T. H prime of T. It's more the placement of the letters is how you say it. All right. Okay, here we go. We're going to turn it. Here we go. Polynomial. F prime of x equals. I'm going to copy my definition, right? Just at the top of the page. I'm going to copy it. F of x plus h minus f of x over h. That's my definition. Notice instead of saying IROC, I wrote f prime. F prime of x equals the limit of f of x plus h minus f of x over h. I'm not going to write IROC. I want a different way to represent that. Here's our function. We're going to plug in our two pieces. What did we do first on the boards? First, I plugged in x plus h. Okay, plug it in. Okay, so take a minute, right? Expand it. Okay. I don't see any like terms. Notice how they're all different. Okay. That is the y value, right? That's the y value. I plugged it in. That's the result. Now I'm going to write down f of x. This is the y coordinate. Think about what we just did. I've plugged in the two things. I put them into the formula. There is no number. I don't have a number for x. Notice I didn't say find instantaneous rate of change at x equals. I just said find the derivative. That means f prime of x. Okay, let's write down our limit statement. F prime of x equals. We're going to plug in our two pieces. It is a little bit long to start, but it shortens pretty quick. Okay, I'm going to distribute my negative right here, but I'm not going to rewrite the whole expression. I'm just going to show the distribution, and then I'm going to look for all my like terms in the numerator. Okay, cancel out. And things are going to cancel out pretty nicely. It's how the formula is built. Okay. I'm going to try really carefully not to like miss anything. So h squared. Oops, 6h. I'm just kind of putting it in order. I just put my high power first. Can I factor the h out just like you did in the warm-up problems? The h is still going to factor out. Okay, factor that h out. Okay, I wrote a little bit big, but I think I can do it. Okay, equals. I'm ready to plug in 0 for h. Our only goal today is to be successfully able to evaluate that limit statement. That's all I want you to be able to do today. Careful with the signs, combine the like terms, careful with the negatives, factoring. And so I'm going to write down f prime of x equals 2x minus 6. Notice I don't have a number. That's it. This is the derivative. It's an expression. It's a formula. What else did I say? It's an equation used to find the tangent slope. I just want you to be able to write f prime of x equals. We will spend a lot of time actually interpreting it. I just want you to be able to find this equation today. That's it. All right. Very similar problem in number 2. See if you can work through some of those steps and see if you can find f prime. All right, you guys try number 2. Just giving you some guidelines here. Okay, there you go. Trying to plug in those pieces. Okay. Okay. Very similar steps to the one above it. 2x plus 2. 2x plus 2. That's what you should be getting. When you get into the actual formula, then they're going to cancel. Yeah, I don't actually expect them to cancel when you're plugging in x plus h. There's too many letters to get like terms. We're going to do these three, but while we're doing those, you can try to catch those. Because these are all problems.
6.
No, we're going to do them fast. Pick like a few.
Okay. And then it should be minus.
Yeah, your homework is to just finish it.
I think it says
23rd, which is not even. I changed it 25th, which is actually a weekday. But all right, you should have 2x plus 2. All right, so let's see what we have. Okay, so x plus h squared. X squared plus 2xh plus h squared plus 2x plus 2h. Nothing simplifies. This goes here. Oh, 2x plus 2h. Okay, x squared plus 2x. Okay. Right, it's subtraction, so be careful with that distribution. Okay, and then I look for my like terms, and everything with x's cancels out. Okay, this is all over h. The limit as h approaches 0. 2xh plus h squared plus 2h all over h. Okay, so I can see that the h is going to cancel. h, 2x plus h plus 2 over this. And then I plug in 0. 2x plus 2. F prime of x equals 2x plus 2. All we're trying to do today is to successfully get to this f prime of x equation. That's it. Just get here. Okay, so those two were polynomials. We're going to do one radical and one fraction. Okay. Give it a try. Okay, so let's set it up. Let's see if we can do it. F of x plus h. Oh, there's actually, that's it. There's nothing else to do. Okay. F of x. Okay, I'm just going to come back up here and rewrite my statement. The limit as h goes to 0. Okay, 1 over x plus h minus 1 over x. All right, that's me plugging into the formula. Try to simplify that statement. I'll put the answer down here so you can check. Okay, see if you can get there. There's your statement. Common denominators. Multiply by reciprocal. If you get number 3, go ahead and try number 4 there.
Yeah, correct. Okay, so, that's fine. Parentheses, PEMDAS, you have to do this before you do that multiply. Negative. Likely right here. I'm pretty sure that's a distribution. Okay.
All right, if you get number 3, make sure it's negative 1 over x squared. Careful with your distribution of that subtraction in the numerator.
I don't think I did it right. So this is actually x minus x minus this is.
Okay, now keep in mind this is a negative 1 in the numerator.
It's also there.
So you're right. Plug in 0 for h. Negative 1 for x. Yeah.
Oh my god, I got it.
Okay.
Yeah.
Okay. So this is me plugging in.
How are you going to combine those?
Start there. Okay. I'm going to zoom out and put the next one up. I'm going to work them out, but if you get there before me, you can check. The second one should be 1 over 2 root x. Okay. I'm going to work out all the steps, but give it a good shot before I put up the work.
I didn't do it correctly. That's what I got. Oh wait, no. I think just oh yeah. Oh, it's over
I'm going to say plug in 0 for 8. I think I did it right. Yes, good. Yeah, you're right. Oh my gosh, wait. You have simplified. Yes, you got this. Good?
I know. Why is your work so like
That's
okay,
there's no
numbers here.
This is it.
Oh, I was like, so you oh, I think I accidentally. There's absolutely no number.
And you forgot to put your well,
Oh, it's minus 8 here.
Oh wait, no, it's not that.
Oh, I didn't. That's what I got.
Okay.
No, I got the same thing. Oh, the negative is here.
Right here when you rewrote your conjugate, you just did that just h over h.
Okay, I have that. Yes. Wait, why would it go?
Yeah, you just
Yeah. Okay, when you wrote your conjugate, you just right.
Oh, see, yeah. What?
That's fine. Your x plus root x is 2 root x.
Yeah, whatever.
Yeah.
Question? No questions. Just
Okay.
you guys, I got it.
no, you continue to.
What? I'm right?
Yeah, but you're not.
I'm not there. Oh my god, I'm there. I'm not there. Oh, I guess when I think. Should we plug in the 0?
All right. Let's work them out together. Okay, so common denominators. 1 over x plus h. I need to multiply in the x. Here, I need to multiply in the x plus h. Okay? And so I get x minus h. Okay, so, oh, sorry. Okay, these two things cancel. So I am left with big fraction bar over h. The limit as h goes to 0 of negative this over multiply by reciprocal. Okay, this cancels, and I get negative 1 over x. Plug in. All right, we're going to go right into number 4. F prime of x equals root x plus h. Oh, I forgot the important part. The limit as h goes to 0 minus over h. Okay, conjugate, that's what I need to multiply by, plus, okay, first, outer, inner, last, okay, don't forget your limit. Okay, I noticed that this and this are canceling, and I have h. All right, guys, hold on. You can do it. Stay with me. Okay, cancels. And plug in 1 over x plus 0. 1 over 2 root x. 1 over 2 root x. This is the result you are aiming for. Guys, we will learn how to use it today. I just want you to be able to find it. Okay. Here is your task for the remaining, 20 minutes of class or so. You can group up into however many people you want to. Doesn't matter. I want you to do maybe 2 questions from, you see there's 6 on this page. There's 6 on this page. Or sorry, 2 on this page. It's multiple choice. The answers are right here. Pick 2 of them maybe and solve them, right? Find that limit statement. But notice, I would like you to look for a pattern. If you know it, don't say it. Okay, if you know what the pattern is, don't tell them yet. Okay, but I told you get to say goodbye to limits. You don't actually need limits after we learn the pattern. Now, why do I say that? How many of you want to do x plus h to the 4th power? Yeah, it's like, I could do it, but it would take a while. A lot of multiplying. After about power 2, it becomes a little tedious to do this limit statement. Like, we did it. We factored, we expanded, we reduced, but it becomes tedious. There is a faster way to do it, and that's what I want you to look for. All right? So pick about 2 of them, match them up, write your answers, and then look for a shortcut to get from the original statement all the way to the answer. All right. There you go.